Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. My name is Judy Tomei. I am joined by Dr. Elena Hyde.
Hello.
Hi, Elena. We are
Hey.
broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 1 a.m. Universal Coordinated Time. The York Universe production works in concert with our online public viewing program run by the Observatory team. Hi, team! Which runs between the hours of 9 and 10 local Toronto time. You can head over to yorku.ca/science/observatory and follow the links to OPV, that's online public viewing, and join in the chat there. For any questions or comments you have about our past shows, or if you have suggestions for future topics, you can send us an email at observe@yorku.ca. You can always join us on socials. On Instagram, the handle is at YorQ Observatory, and on Facebook, we are found at Allan I. Carswell OBS. All of our programs are free, but if you would like to make a donation, we certainly won't say no. And all of that is over at our website at www.yorku.ca/science/observatory. We'll be monitoring the chat for questions to post content. The current weather is good, but I understand there were some problems with getting the system to cooperate.
Yeah, our all-sky camera has been a little bit on the fritz, and it's just not safe to open without it, even if it says it's clear. It's like trust and verify is the right process, and without the all-sky camera actually turning on, we can't verify. So we're going to give it a few more tries throughout the night. If you are an expert in Skywatch 4.3.13, feel free to email us.
That's observe at yorku.ca.
Exactly. But if you are not, we'll just have to do the usual thing, which is we turn it on and off again and wait until it starts behaving. For some reason, at the moment, it behaves very, very well after dark, and the sun sets so late at the moment that it's still misbehaving. So we're going to give it a few more tries. If we can, we'll go ahead and start it up and open the domes. And if we can't, we have some wonderful images being put up from our archive by our amazing online public viewing team over there on YouTube. So you won't miss out either way. But I have to say, I am really looking forward to these sunsets getting a little bit earlier.
I have mixed feelings.
Well, it will definitely help with the more observing aspect of our lives.
Fair, I'll give you that.
It might not help with other things.
Yes. Um, awesome. Other than that, things are good.
Yeah, I think things are, other than that, we're doing quite well. I'm really excited to have so much, interesting stuff happening all the time. It's a little bit overwhelming because every time I look at space news, I'm like, oh my gosh, all of this is going on still. But yeah, may you live in interesting times, I suppose. And here we are.
Yes. Let's start with the interesting times of the past, as is our
Let's.
usual order of operations. Let's get started with our This Week in Space and Astronomy History. What have you got for us?
Well, I'm going to go way, way, way back. And this is officially a long, long time ago. We're going to go all the way back to 451 AD. And I actually know that it was the 28th of June by our current calendar, rolling backwards in time. Obviously, in 451 AD, they were not using this calendar. But we know the date this precisely because of what happened there. And this is a really fun thing in in astronomy and history and the whole regime called archaeoastronomy, there are some astronomical events that are so noticeable and so datable that they can actually be used to date moments in history accurately and also to trace back the history of astronomy. So in the 28th of June, 451 AD, they had one of the most regular, repeatable, visible astronomical events that we know of. And this is Halley's Comet, or what is now called Halley's Comet. It certainly was not called Halley's Comet in 451. It was discovered by all kinds of people throughout the history of sky watching, I suppose. And there are records going back to ancient China, as I believe that probably the earliest records. Um, there are, of course, records going back through all kinds of significant points in history, but Halley's Comet had a pass in 451, and because we know its orbit fairly well now, we can trace it back and find out that it was actually on the 28th of June, 451, that Halley's Comet appeared before the defeat of Attila the Hun at the Battle of Chalons. This is amazing because it's quite a fun moment in history. I mean, maybe not for Attila the Hun because he did get defeated there, but this makes astronomers and historians and archaeoastronomers all very, very happy because we can use our knowledge of orbital dynamics and how orbits work, and of course use historical records to match up the records of the time, which did record a comet appearing before the defeat of Attila the Hun. And we know approximately when that would have been, 451. And we also know by tracing back the comet Halley with our astronomical knowledge and, a big pile of math and or code, depending on how you roll, um, we can actually show that there was Halley's Comet that would have been visible from Earth exactly around that time, and therefore this must have been that event. And so we can actually match it up. Of course, we know a lot about Halley's Comet now. Of course, we've seen records going back to the Babylonians and the Chinese. There was a fairly famous set of observations done all the way back in 12 BC. So that's where we're not right now. In case of people losing track, we are now in 2024, which means at some point if you go back far, if you go back 2024 years ago, you hit zero, right? But there's no zero on the date line, so you then start going 1, 2, 3, 4, 5 in the other direction. And so 12 years before 2024, this amount of days, this amount of years actually started, Halley's Comet, and actually there's a -1 in there, carry the one. So Halley's Comet was watched by the Chinese for 2 months, and they had 2 full months of detailed comet observations. And so the fact that this comet has been so visible for so many people throughout human history really makes it a wonderful thing for This Week in Space and Astronomy history, but also for archaeoastronomy and for history in general. And the fact that the comet does have to happen to be so noticeable, it's a little bit of a correlation effect. But when there were important things happening and this comet happens to go by, it did get a little bit of a reputation as kind of an omen. The comet was sort of heralded by kings at various points, and it's just been described by cultures all over the world. Tamil literature, actually talks about the death of a king after the appearance of a comet. It was described by Romans, extensively described by the Chinese, of course. Of course, in 451, all the way back, you had Attila the Hun, who was battling. at the Battle of Chalons, and that's Chalons. So I'm probably saying it wrong. I realize. And for those of you who don't know, Attila the Hun is a pretty famous figure out of history. He was the ruler of the Huns, who were a nomadic people living in Central Asia between the 4th and the 6th centuries. And would have been, um, Europe adjacent. And they were first reported living sort of east of the Volga River, and that area was part of Scythia at the time. So this is early empires. Attila and his, was obviously the ruler. He had quite a storied history. So the history itself is really really quite interesting. He invaded Italy, was planning to take Rome. Very very active fellow. But unfortunately for him, the Battle of Chalons, which is I think sometimes also called the Battle of the Catalaunian Plains or Fields, this was a not one that he was going to win. So this was between the Romans and the Visigoths against the Huns. And Attila, of course, being on the Huns side, was was hoping to win that, and long story short, he didn't. So the date of the battle actually is secured to June by the entries of a chronicle that was written a little bit later. It's called Hydatius. Again, some of these names I'm probably not saying completely right, but Hydatius's chronicle actually records the battle and places it in between the appearance and disappearance of Halley's Comet. So he was keeping a chronicle showing what was happening in what order, and the Halley's Comet appeared, the battle happened, and then Halley's Comet disappeared. And so this was the battle itself has lots of other records from all kinds of different um, places, but Attila did not win this one. So it was a really interesting time in history, really interesting comet, of course. And Halley's Comet being repeatable, we can look forward to it coming back again. Um, you know, uh, not uh, um, not too soon, but 2061. So it is now 2024. So good news is it's less than 40 years um, until Halley's Comet actually does come back. Bad news is it's not going to be particularly soon. So Halley's Comet is named after astronomer Edmund Halley, who was not by any means the first person to see it, but his observations of the comet, with, of course, and sharing those observations with Isaac Newton, helped to revolutionize physics as we know them. So pretty revolutionary, but maybe not entirely accurately named comet. Now, if you want to see some really cool pictures of Halley's Comet, I will just say that there have been some pretty good images taken. Um, there was a 1986 visit to the inner solar system where they made sure to actually get close-up images of the time for Halley's Comet. And until we get it coming back in 2061, which should be pretty darn exciting as we're all still here to see it. We should be able to get some much better pictures then. I hope. I'm really hoping that they get one of those spacecrafts that actually fly out to meet Halley's Comet, and maybe land on it and walk around or something when it's still far
Ooh.
enough away from the sun for that to be safe. just to be clear. But yeah, it's really really great if you love historical writing and you love history. There are possible reports of Halley's Comet in the Talmud, and in religious texts from around the world, as well as ancient chronicles and you know some really really cool drawings from the tapestries even. It's great stuff.
Well, as a museum educator, I love when astronomy and history smash together.
Oh yeah, absolutely. And I mean, especially there's so many museum level artifacts literally about this comet. Illustrations portraying the comet, as I say, tapestries, even engravings. It appears in various zodiac maps. Yeah, there's of course, there's even some from the famous Chaco Canyon, or the Chaco Native Americans in New Mexico, petroglyphs showing
Oh,
this
that's so
comet.
cool. Okay,
I
you
know.
have just created my next rabbit hole of research. Thank you.
It's so fun. It's so fun. So look up the petroglyphs at least if you do nothing else.
I think I will. Petroglyphs are amazing. Um,
Speaking
awesome.
of amazing things, I suppose.
Yeah. I also hope that I have the longevity of my great grandfather and my grandmother so that I'll be around in
Yeah, if you aim for like
2061.
aim to be like one of those 110-year-olds that nobody can explain how they're in such good health.
Well, I mean, it's
Like
40
that's
years from now, so I don't have to be quite that. I just have to make it into my 80s.
yeah, but if you
It's
aim
not
for
unreasonable.
110, then,
I mean, 110 would be great,
yeah.
so long as I'm still, healthy.
Yeah, yeah. That's what I'm saying. If you're gonna aim for 110, definitely aim to be one of the really healthy people.
Yeah, yeah. When they ask them, like,
Anyways,
how'd you get to be that old? They're like, I don't know. I just live, laugh, love.
yeah, exactly. It's like, well, and then sometimes people are like, "Oh, drink 4 bottles of vodka every day or something." I don't know.
Don't
Don't do
think
that.
that's the answer.
No, no, definitely not. Wouldn't work for me. Anyways, however you want to get to your next comet viewing, um, hopefully we're all here to see it. But there will be some more comets coming by before then, so don't worry, folks.
If you need a special kind of motivation to take care of your health,
Yes,
then maybe it's
astronomical.
seeing Halley's
Yeah,
Comet in 2061. There you go.
absolutely. And take care of your eyesight as well.
That too. Or else you'll have to have someone describe to you what they're seeing. Described audio, Halley's
Mm.
Comet. All right.
3D renderings will be better by then.
Ooh, cool.
Anyways,
All right. We digress.
we do so much.
We tend to. It's all good. Okay. Let's come a little closer to the present time, but not that much closer.
Yeah, something
Um,
equally spooky, it sounds like.
yes. Ooh. All right. So June 24th, 1883, Victor Francis Hess was born. That's not the spooky part. Um, he was an Austrian American physicist who discovered, or I guess postulated, the existence of cosmic rays. So they were, somewhat mysterious at the time that he postulated them. And for that work that he did to come to that conclusion, he was awarded the Nobel Prize in Physics in 1936. So Hess was born at Schloss Waldstein. That it means a Waldstein castle near Pegau in Styria, Austria. And at first I was like, well, la di da, he was born in a castle. Then I read his father was a royal forester. So, you know, father
It's
worked at the castle.
fancy adjacent.
Fancy adjacent, yes. He attended the University of Graz from 1901 to 1905 for his undergraduate studies and received a PhD from the University of Vienna in 1910. And from there, he went on to work at the Institute for Radium Research at the Viennese Academy of Science from 1910 to 1920. So it was work that he did there between 1911 and 1913 that won him the Nobel Prize. Scientists have been puzzled by the levels of ionizing radiation in Earth's atmosphere. The assumption being that the Earth was the source of the radiation, and so the radiation levels should decrease with increased distance from the surface of the Earth. Hess first improved the precision of the equipment used to measure this radiation, and then he went in a balloon at various altitudes, up to an altitude of 5.3 kilometers during both day and night. Guess going up over 5 kilometers in a balloon is dangerous. Everywhere I read, it was like at great risk to his own self. Um,
Yeah, well, this was pretty early on in
yes,
efforts of flight in general. So this
anything
would have
for
that
science.
yes. Talk about motivation.
Yeah. So the results were that the levels of radiation decreased up to about 1 kilometer, and then they increased considerably um, with the radiation at 5 kilometer altitude being twice that at sea level. So Hess's conclusion, there's radiation coming from outer space. Ooh. And this was confirmed by Robert Andrew Millikan in 1925, who coined the term cosmic ray. This led to more discoveries in particle and nuclear physics, such as the discovery of the positron and muon in cosmic rays by Carl David Anderson, with whom he shared that Nobel Prize in Physics in 1936. He married Marie Bertha Warner Breisky. I possibly butchered that last name, in 1920, and she was Jewish, and that will become important in a few years. Um, he took a leave of absence in 1921 to work in the United States at the United States Radium Corporation in New Jersey, and also as a consulting physicist for the U.S. Bureau of Mines in Washington, D.C. And then in 1923, returned to the University of Graz, where he was appointed professor of experimental physics in 1925. The University of Innsbruck appointed him professor and director of the Institute for Radiology in 1931, and he relocated to the United States to escape Nazi persecution in 1938. Told you it would become important. He was appointed professor of physics at Fordham University, got his US citizenship in 44, and retired from Fordham in 58 and died on December 17th, 1964 from Parkinson's. So this is early work that got him the Nobel Prize, but sounds like he did a lot of work after that at a lot of different universities all over the place.
Yeah, and I mean, of course, this is one of the many many scientists who did um, land in the U.S. After the war, or escape Nazi persecution by coming to the U.S. Of course,
Mm.
Einstein as well. But it is one of those things. This cosmic ray discovery was such a big deal. And I think we should totally emphasize that because this was 1883, mysterious rays from space. And this just captivated scientists and science fiction writers, and like, what could it possibly be? Where could it come from? Cosmic rays are still studied today actively.
Yeah.
They are not at all a completely solved problem. And okay, it comes from space, but I mean, how much, where, what kind, how much of them are from our own sun, and does it, how does it work? And because they get scattered by our atmosphere, the directionality is often really, really hard to get on these, and they are they are really, really, really interesting noise. And so if anyone has ever tried to take a picture of the sky with a CCD camera that holds the exposure open, you'll get these little white blips that show up on your CCD. Those are cosmic rays. The noise that you get from watching the sky, just with your CCD camera open, those are all cosmic rays. I mean, obviously not the lights on Earth and all that stuff. There are other sources of noise. But figuring out where they come from and how they work has been a super super mysterious process, and people still argue about exactly how much come from where. So
Yeah, and I mean, cosmic ray, the term itself is a bit of like a catch-all, right? It's like
yeah,
radiation coming from space. So a lot of things fall into that category, and a lot of different instruments have been developed in, the century plus since uh this was even theorized or postulated. Um, I remember going to the Ontario Science Center and looking at that chamber of liquid in a dark room, right? Where you just kind of wait. And then there's like a little
yeah,
streak of, is it bubbles? Um, and going, okay, that's cool. That thing came from space. Awesome.
yeah, exactly. And it's, I mean, as you say, they come from lots of different sources. These are any kind of highly energetic particles that strike our atmosphere and will bounce around like this to create what we call cosmic rays here on Earth. These little tiny bits of light that come into our CCDs and into our tanks for detection. But it could be from our galaxy, it could be outside of our galaxy, it could be from our sun. Um, it's yeah, really, really interesting stuff.
Do neutrinos count as cosmic rays?
I don't think
Okay.
so. That's actually a really good question. You know what? Maybe.
I don't know.
Now that
I'll look it up.
my initial thought was no, but now I'm like, actually, high energy. We have highly energetic, all kinds of things, and neutrinos are pretty high energy. So sure. Maybe there's an argument somewhere about who counts neutrinos for what part. But the cosmic rays that we usually discuss, those are the ones that interact with our atmosphere and will cause these cascades of particles. So neutrinos being very uninteractive wouldn't cause a lot of the neutrinos, or I mean, sorry, wouldn't cause a lot of the cosmic rays that we actually detect on CCDs.
Okay. So,
And that said, I am not a cosmic ray expert. I just remove them from a lot of frames of data.
the answer that I found is that they are intimately connected
I mean,
because
they are energetic
cosmic,
particles.
yeah, cosmic neutrinos are generated by cosmic rays in extragalactic sources and can be thought as cosmic accelerators.
I mean, maybe it's just for secondary cosmic rays. Like if all you have to do is create a particle cascade to be a cosmic ray, then sure. But I would invite everybody who really wants to know about this to go to a website for the Large Hadron Collider or similar, where actual proper particle physicists will tell you every single kind of energetic subatomic particle.
Yes. And I'm sure the Snow Lab website can tell you
Yes.
all about
And
neutrinos.
actually, SnowLab has free Python code that you can download and run if you want to see the path of some of those particles through their detector.
Nice.
Yeah, it's pretty cool.
That's fun.
At least it was there last time I looked on the website. um,
Amazing.
but yeah, cosmic rays, super fun.
Okay. You want to take us to a galaxy far, far away?
I do. Speaking of strange things from space, this is going back not even as far. So we've sort of zipped through history here. I'm only going back to 2015, but it's June 24th, 2015, which I'm like, oh, it was just yesterday. It's almost 10 years ago. So June 24th, 2015. the Swift telescope, using its UVOT XRT instrument, started a series of observations for a mysterious superluminous supernova. And this mysterious superluminous supernova was detected a few days before. It has a terrible name. You'd think they would give it something a little bit cooler, but it's just called ASASSN. So ASN and then SSN is supernova. So it looks a little bit like assassin, which is the coolest name link I could find. ASASSN 15 LH, or supernova 2015 L. L is for luminous because at the time in 2015, this was the most luminous supernova that they had found. They had found other things that were more luminous, but this one, they were pretty sure it was a supernova, and it was had a much brighter magnitude. So in the sky, for its distance, it was too bright. It had more luminosity than they were expecting it to have. Um, it was in a galaxy far, far away. So it was at a redshift of zero point 0.2 over 0.2326, which is, not the distant universe, but it was pretty far out there. And at this extreme distance, it actually got to a magnitude which would have been almost twice that what any other previous supernova that they had seen. It had interesting features. So they're watching the light for this bright thing in a galaxy far, far away. And it got brighter and brighter and brighter until it was brighter than the galaxy it was in. At its peak, it got to be about 570 billion times brighter than our sun, 20 times brighter than the combined light of our entire Milky Way galaxy, if it had been at that distance. So this particular supernova, or in quotes, supernova, was outshining the light of its galaxy and many times more luminous than our own galaxy would have been at that distance. So it's really quite a mystery. In the 4 months since it first was detected, it radiated a tremendous amount, and I won't even tell you the number of ergs because it's ridiculous. The real question was, what could be causing this kind of supernova? What could it be? And they thought maybe it would be a highly magnetic neutron star or white dwarf, what's called a magnetar, perhaps. There could be a magnetar model that could somehow increase its energy output, and it firmly put itself in the less explained category of supernova. So the total emitted energy, as I say, for this one, there have been things that have been brighter, but not things with quite this light curve. And so when it was first found, it was interpreted as the most luminous supernova, and they changed it so that it would actually be okay. Well, we're not entirely sure about this light curve. We're going to call it a supernova-like object. So the supernova designation is actually a little bit under debate. So they said, okay, well, maybe something else was going on. We're going to call it supernova like. And because it's in a galaxy outside of the Milky Way, this is a tremendous distance. So if you remember the Monty Python song, the Milky Way galaxy, 100,000 light years side to side, it's approximately correct, 100,000 light years. That's how big we are. This thing is 3.82 billion light years away. So usually we talk about, that's why I said redshift is zero point 0.2. It's far out. It's far out there. And it was still very, very well seen. The current popular debate in literature, at least what I could find, is that maybe there was some sort of tidal disruption event around a supermassive black hole. Maybe there was gravitational lensing. There's even people who have proposed what's called a quark nova. Speaking of subatomic particles, this
Ooh.
is a hypothetical super violent explosion when you convert a neutron star into a quark star on the way to becoming a black hole, maybe. um, but the whole quark star and quark nova is definitely a fun rabbit hole to go down. It could be inside a Wolf-Rayet star, which are these stars that have incredibly high winds. And of course, as I say, the magnetar, which is this super, super, super strong magnetic field in a neutron star. And that can create some really extreme conditions. So they still don't really know, there's a lot of arguments one way and another. What caused this supernova-like explosion from space? It had all kinds of interesting things that they saw in its light. So when they're observing the light, they can tell what kinds of chemicals it has in it. All the stars we know of are made of hydrogen and helium, but the spectrum of this supernova had no hydrogen or helium lines. Ooh.
What?
I know. It had lots of really interesting things, and of course, being in another galaxy means the resolution was, terrible. All we could do is say that it was incredibly, incredibly luminous, and what that light consisted of. Um, so super luminous supernova, very very fun, and still one to argue about. I am personally very surprised they haven't given it a better name by now.
Oh, we're terrible at naming things.
We are. I named all my cats after astronomy things, so I can say
So your cats are called HD 3702?
quasar.
That's much better. Uh,
Quasar and Nili Fossae. If you know which astronomical objects those pertain to, then congratulations, you have won the trivia for this episode.
nice.
Um, all right.
Okay.
So that's my very mysterious, spooky light from space.
Amazing. Okay, folks, if for some reason you are just tuning in, I'm here to tell you that you're listening to York Universe, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. You can head over to yorku.ca/science/observatory for all things Allan Carswell Observatory. Um, you can go to Instagram for at Yorku Observatory for all things observatory. Tonight, you are listening to myself, Jeannie Tomei, and Dr. Elena Hyde, and we are just about to wrap up our This Week in Astronomy and Space History. We've got one more item left. So let's get to it. And
Talking
that,
about mysteries, boy.
yeah, this one's kind of cool. It's one that I think a lot of people know about. And since a lot of people know about it, maybe don't realize how mysterious it is. This is June 30th, 1908, and the Tunguska event. So this was a large explosion. Estimates range between 3 and 15 megatons energy wise of this explosion that happened near, okay, I'm going to try, the Podkamenya Tunguska River in Siberia. Uh, it flattened an estimated 80 million trees over an area of 2,150 square kilometers. Up to 3 people may have died in the event, and its cause is widely attributed to a meteor airburst of a stony asteroid, estimated at a diameter of 50 to 60 meters and an altitude of 5 to 10 kilometers above the ground. It happened a little bit after 7 a.m. local time, and it was observed by Evenki natives and Russian settlers in the hills northwest of Lake Baikal, who saw a bluish light, almost as bright as the sun, moving across the sky. Close to the horizon, a flash was produced, and there was a flash and it produced a billowing cloud, and a pillar of fire cast a red light. It sounded like artillery fire, and a shock wave was produced, knocking people off their feet, breaking windows hundreds of kilometers away. The explosion registered at seismic stations across Eurasia. Airwaves were detected in Germany, Denmark, Croatia, the UK, Batavia, the Dutch West Indies, Washington, D.C. Um,
Wow.
yeah, right? Like other side of the planet, clear on the other side of the planet. The sky in Asia and Europe glowed over the next few days, likely because of light passing through high altitude ice particles that formed at extremely low temperatures because of the explosion. Um, the Smithsonian Astrophysical Observatory at Mount Wilson observed a decrease in atmospheric transparency for months, as well as an increase of suspended dust. Because of the remote location and the limited instrumentation available, scientific interpretations as to the cause and the magnitude of this event have relied on damage assessment and geological studies that were done long after the event. Those studies started only a decade after the event. There was a Russian mineralogist called Leonid Kulik, who led a survey in 1921, and based on local accounts, persuaded the Soviet government to fund an expedition to the impact zone. So it took them a while to do that persuading. So the full expedition didn't happen until 1927, where Kulik hired Evenki hunters to guide him to the site where he expected to find a giant crater. Instead, he found a zone approximately 8 kilometers across, where the trees were scorched, had no branches, but were still standing. And trees farther away were partially scorched and knocked down. So it created this radial pattern on the ground. He led three more expeditions over the next decade. Aerial photography was taken. There were expeditions like continued over the next decades. There were some in the 50s and 60s where microscopic silicate and magnetite spheres were found in the soil, and the same were later found in resin of the felled trees. The ratio of iron to nickel in the samples is consistent with that found in meteorites, and the concentration of spheres in the soil is consistent with the expected distribution of debris from a meteor airburst. Um, Peat bogs in the area have been analyzed and show anomalies that are consistent with an impact event, such as elevated levels of iridium, similar to the iridium layer found in the Cretaceous Paleogene boundary. And for those of you who don't geek out on dinosaurs like I do, that's the boundary in rock layers that shows up after the dinosaur killing asteroid slash comet smashes into Mexico. Um, so like lots of data points, but like all gathered quite a bit later. So like it's a case of like it being really interesting what we can do when we
Yeah.
go to a place. Also kind of lucky that it happened in a remote location.
Oh, so lucky.
So
Because
lucky.
that's absolutely a massive area of destruction. And I mean, a remote area, well, very, very, very low population. For the humans, I think this is probably the best case scenario.
Yes. It does limit what, the what and the when the science could be done, but the level of catastrophe that it would have been had it been over, I don't know, it happened in
People,
Russia. If it
place.
happened over
Yeah,
Moscow, like it
yeah,
would
yeah.
have been awful. And I like a good mystery.
Yeah, and I mean there are so many interesting theories for what it could have been as well, right? It's like, yeah, it could have been a stony asteroid. But I remember reading people theorizing about, micro black holes and exotic things that could have, fragmented neutron stars. And I mean, there are people doing some just really, really fun calculations based on the lack of debris and the size of the explosion.
Yeah.
Um, but yeah, absolutely, absolutely, as you say, great stuff.
All right. So,
And great that it wasn't too close to us, where the people live.
yes. Yes. Absolutely. Okay. So we have a reminder this week.
We do. We have a new astronomer in residence out at Killarney Provincial Park starting
Yay.
today. And I mean, by today, I suppose I mean tonight. So if you haven't heard about the astronomer in residence program, definitely check that out on that same website as before. yorku.ca/science/observatory, and then you just do /air or click on astronomer in residence. And whoever is up there now will be writing in their blog. So right now we've got Veronica Dornan, who just started today. She's going to be doing her first blog entry sometime tonight or tomorrow. And she's the second astronomer in residence of the 2024 season. We're really excited to have her up there. So it's always a new a new week, new astronomer, new adventure. And I'm hoping that we can do some live streaming with some of our astronomers this summer as well. What do you think about that, Julie?
Sure. I just have to know how to do it. I'm willing.
Oh
I
yeah,
just
absolutely.
need to know how.
Um,
Um,
well, and for those of you who don't know, Julie will be going up later. So
yes.
I'm hoping that we get lots and lots of folks out. We have, of course, video programming. And if you are on site and you want to get more than just the blog and the videos and the pictures, you can go to the observatory at Killarney Park if you're hiking there or camping there and check out what kinds of programs are happening with the astronomer in residence the week that you're there. So this week, actually, our astronomer in residence is scheduled for four different shows. They're doing solar viewing on Wednesday. They're doing evening amphitheater talks on Wednesday night, and then they're doing a tour of the night sky at the observatory on Friday and a Saturday show at the beach. So they've absolutely packed in activities this week out at Killarney Park with our astronomer in residence. So I'm really happy for her and I'm really excited about it and I hope everyone else is too. So
Nice.
yeah, first astronomer in residence. Well, I suppose second astronomer in residence, but the first one that hasn't been before. So this is her first term, and it's always nice to see someone get to grow up for the first time.
Amazing. A great
So that's
time,
all the
Veronica.
announcements fit to print. Obviously, there is a Wednesday tour as well. So if people are watching this thinking about going on Wednesday at the Allan Carswell Observatory at York, substantially closer to Toronto, on Wednesday, the 26th, we're having an observatory tour. So not at the atrium, at the observatory.
Ooh,
Yeah, very
go get
fancy.
those tickets, folks.
Yeah, it's the only observatory tour for the next 3 4 weeks. So then it's atrium tours after that until the end of July.
Go get those tickets, folks.
Yep, they're free. No
Yeah,
reason not to.
free tickets to see a beautiful telescope. You
Oh
can't go
yeah.
wrong. You can't go wrong.
Um, and hopefully it'll be clear on Wednesday as well.
But even if it's not,
Even if it's
you
not.
get to see the telescope.
Yeah, and there's a treasure hunt. So if you find all the 6 hidden items, you get a prize.
Nice.
All right. So shall we go into other news items
Let's shall.
of
I'm
the week?
excited for your news item.
So we've been talking about interesting things from space in history, but in today's in today's Canada, we have other problems. So last week we talked a lot about space junk, and in particular, last week we talked a lot about the space junk that had just hit Saskatchewan and all these massive pieces of SpaceX space junk that came down last week. This week, there's more space junk that came down, and this time it hit someone's house.
Ooh.
So we're literally a week later, different piece of space junk crashed through 2 floors of a family home in
Yikes.
2 floors of an actual person's actual house. The debris went through the roof and through the floor, nearly hitting an actual person that was in the
Oh,
home. So the according to the family there, and this is in Florida. So this is in the news now. If you don't believe me, look it up. It's on all kinds of news sites. But this family, they got the space debris, and they were very very happy, obviously, that nobody was injured, but their house was pretty injured, and they had people that could have been injured. And it was just the other week we were talking about Saskatchewan. Thank goodness none of those giant pieces hit a building. Well, the debris came from a 2.9-ton pallet of used batteries that had been
mm.
thrown off the International Space Station, because that's how they get rid of their garbage in space. They just throw it out into space, but it's in orbit, and so it came back down. So NASA did confirm that the debris was definitely from the pallet of batteries that had been jettisoned from the International Space Station, which is in low Earth orbit. So it was definitely their stuff that hit these folks' house. And at that point, the house in question and the family in question were kind of asking, "Can we please have some funds to repair our house because your stuff broke our house, through not just through the roof, but through another floor. So two different floors got impacted. That's a major major house repair you're looking at, and of course NASA did not agree, and the family actually had to take them to court. And if it was there is actually something called the Space Liability Convention. So space law is a pretty new field, and there's a lot of things we don't know the answer to. But this is the first time we know of space junk destroying someone's property. While they were in it, the folks in Saskatchewan did also get, so SpaceX reimbursed them some unknown amount right away, but these guys in Florida, they did not get any reimbursement, and so they actually had to sue NASA to ask for reimbursement. And there is a convention that says, if debris falls in another country outside of the U.S., NASA should be liable. If it's your debris, you're liable. But since it's from the U.S. and it landed in the U.S., anyways, now they have a court case. Because they're trying to not pay, I suppose, and now they're trying to get precedent for how are governments and private space companies going to handle compensation, because we've now seen space junk come down and impact several farms in Saskatchewan in Canada. And now, just a week later, NASA space just junk came down and literally went through someone's roof and floor, 2 different stories, damaging their house and almost hit a person. So, how are we going to assign um, uh, future victims compensation, and what are we going to do about the space junk? Because it's only going to get worse. This is not something that is going to immediately cure itself if we keep dumping things in low Earth orbit. They're going to keep on falling back to Earth, and they're not all going to burn up. So it's quickly become a hot button issue because it's like, yeah, this is actually happening a lot. And if you look at the actual pallets that they use to jettison the debris, they're huge, they're massive. If it had came down in one piece and crashed through, that would be really bad. So it's yeah. Anyways, in the news now, the last article I saw was published about 4 hours ago. So they are still debating about who's going to pay what, how much. Personally, I hope these guys get their house fixed, but it would be nice to have some sort of, I don't know, regulations in place about what you do with your space junk. Um, Controlled deorbiting was one thought I came to my mind.
Yes. Is it going to take someone dying from this before something happens?
I sincerely hope not.
I hope not
Um,
either.
and it's really the case. We've known about this for years. We've talked about space junk. There have been articles about this since the was it 70s. Um, we have known this was a problem for a very, very, very long time. So there's no excuses. Um, at all. So, anyways, anywho, I think they deserve to get sued and have to pay them. um, but that's what's happening. We'll have to see. We'll have to see what ends up coming from it, and perhaps if there are new regulations that would at least ensure that controlled deorbits are required for large things like pallets full of batteries.
I feel like an easy solution is make the pallets smaller so they actually burn up. What
That
do I
would
know?
be one way to go.
What do I
But
know? I'm,
what do
I'm
we know?
just an educator.
Anyway, I think we have time for one more. So let's do
Yes,
your
let's
let's do your
do it.
iron meteorites.
Yes, iron meteorites hint that our infant solar system was more donut than dartboard. All right. So,
Speak of a
iron
thing
meat,
from space.
right?
It's more
Space
things from
donut or
space.
space dartboard? Um, Iron
Donut.
meteorites come from the cores of the earliest asteroids in the solar system, and they contain refractory metals like iridium and platinum that formed near the sun, but were then transported further out into the solar system. In a new paper published by Bidong Zhang, a UCLA planetary scientist, and a team from UCLA, Johns Hopkins University Applied Physics Laboratory, um, in the Proceedings of the National Academy of Sciences. In their paper, it shows that this, for this to have happened, the protoplanetary disk had to have been shaped like a big donut, and that metals moved outward as the disk rapidly expanded and were trapped in the outer solar system by Jupiter. Okay, so how does this all work? So 4.5 billion years ago, the solar system was a cloud of gas and dust um, around the sun. And then gases started to condense and accrete with dust and to form asteroids and planets. And the refractory metals condense at high temperatures, and so were more abundant in meteorites and were more abundant in meteorites in the outer disk, which is colder because it's farther from the sun. So how did they get there? So,
Mm.
right? Most meteorites formed within the first few million years of the solar system's history. Some are unmelted conglomerations of grains and dust that didn't make it into planets, while others are part of differentiated bodies. In other words, ones that have a core, mantle, and crust, where the different materials were separated, and then that body was pulled apart somehow. Most asteroids are found in the asteroid belt today, and astronomers think that Jupiter's gravity disrupted the path of these rocks and caused them, so disrupted their path, kind of limited them to that space, and also causes them to periodically crash into one another and break apart and send some of this material flying out into the solar system and crash into the Earth, where they become meteorites. And then we collect them and study them. So iron meteorites, as I mentioned, are part of the core material from these early asteroids, and they contain molybdenum isotopes that allow scientists to locate where in the protoplanetary disk they were formed. And then by studying, so the molybdenum tells them, okay, this was formed here, this was formed here, this was formed here. And then they can further study the chemical composition of the meteorite and say, okay, at this part in the protoplanetary disk, this is what the chemical composition was. At this point, this is what it was. At this point, this is what it was. Research using the Atacama Large Millimeter Submillimeter Array in Chile has found disks around other stars have a structure that's like concentric rings. So you'll have like a ring of material and then a physical gap, and then a ring of material and a physical gap. A good example of that is HL tau. Disks like these can't explain our solar system because there'd be no transportation route for the refractory metals from the inner to outer disk. So the research in this new paper suggests that instead of having these concentric rings in our early solar system, it was a big donut. And then the asteroids rich in refractory metals migrated from the inner part where these metals would have condensed to the outer parts as the disk expanded. But after the expansion ended, the metals should have been pulled back in towards the sun, but they weren't. So why? And the researchers think that once Jupiter formed, it formed a physical gap in the disk. And so it trapped those metals in that outer space, outer portion of the disk. And then they were later incorporated into the asteroids that formed there. And if this research wasn't cool enough, this is not the first time Zhang and his collaborators used meteorites to find cool stuff. They've also used iron meteorites to learn how water was distributed in the protoplanetary disk. So cool.
Very, very nice. Talking about things that are actively not understood, but super interesting. Of course, lots more on this, I'm sure, as we keep on getting better and better measurements.
Yes, I just love seeing how, meteorites are used to study the past.
Absolutely.
All right, folks, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. This evening, your hosts have been Julie Tomei, myself, and Dr. Elena Hyde. You can always connect with us on Instagram at York U Observatory and on Facebook at Allan I. Carswell Obs, or check out our website at www.yorku.ca/science/observatory. Thank you for tuning in to York Universe. Clear skies and have a good night.
Clear skies, everyone.